A very warm good morning to one and all present over here class. Welcome to the digital platform of APS. Now this is Pawan Kumar. Today I will discuss some concept related to angle between two lines or whose vector equations are given. See, now topic is angle between two lines. Let us consider L1 and L2 be any two lines whose vector equations are are given by, suppose this is r is equal to vector r is equal to vector a1 plus lambda times vector b1, and vector r is equal to vector vector a2 plus mu times vector b2. Now see, these two vector equation I have considered, and we are going to consider theta be the angle between two lines, and theta is the angle between two lines. Now you know, suppose in three-dimensional space x, z and y, suppose this is the line L1, this is passing through point A whose vector equations are given, and parallel to vector B1. Now this is, suppose this is line L2, and this is passing through, suppose, point B, this is point A suppose, and this is point B whose vector equations are A2, and this is parallel to vector B2. This is the line L2 and L1. Now see, this is the origin, having coordinate 0, 0, 0, and we have to calculate angle between two lines. So line L1, L2 are given, and we are going to consider theta is the angle between two lines. So angle between two lines L1 and L2, when you will suppose theta, when you will extend, so it will cuts, and this angle will be theta. Similarly, this line B1 is parallel to A, the B1 is parallel to L1, and line B2 is parallel to A2. This is L2. So angle between this line L1 and L2 will be the same as angle between B1 and B2. From figure, what we can say? Angle between two lines L1 and L2 is equal to angle between two vector B1 and B2. Now you can see now B1 cross B1 vector dot B2 vector is equal to mod of B1 into mod of B2 vector into cos theta, suppose. Now cos theta, what we can write? Cos theta is equal to mod of B1 vector into mod of B2 vector. So this is the angle between two vectors. We can calculate using this formula. B1 dot B2 vector whole upon B1 mod of B1 vector into mod of B2 vector. This is the formula. Through this formula, we can calculate the angle between two vectors B1 and B2. Now see. If any doubts, can be. Now what is the theory? Or question. First, I will come to the conditions or angle between two lines in Cartesian form. See, so this is in vector form. Now see. Angle between two lines in Cartesian form. in Cartesian form. See, angle between two lines in Cartesian form. Now Cartesian equation of two lines. Cartesian equation of two lines. In three-dimensional plane or three-dimensional space, what we can write? This is x minus x1 upon L, or L1 we can consider, is equal to y minus y1 upon m2 is equal to z minus z1 upon n2, n1. This is the first equation. And second equation is x minus x2 upon L2 is equal to y minus y2 upon m2 is equal to z minus z2 upon n2. This is the Cartesian equation or equation of line in Cartesian form. So there are two equations. And suppose we have to find the angle between two lines. So the angle between two lines in terms of their direction cosines, then the angle between two lines in terms of direction cosine, what we can write? That is cos theta is equal to L1 multiplied by L2, L1 L2 plus M1 M2 plus N1 N2. This is the formula to calculate the angle between two lines in terms of direction cosine. Now in terms of direction ratios, what we can write? In terms of direction ratios, this is the Cartesian equation of two lines, and in terms of direction ratios, we have to write the equation in terms of direction ratio first of all. Now see, cos theta is equal to L1 L2. First of all, I will write this formula, and in next steps now the Cartesian equation of two lines in terms of direction ratio, what we can write? We can write x minus x1 upon a1 is equal to y minus y1 upon b1 is equal to z minus z1 upon c1, and x minus x2 upon a2, y minus y2 upon B2 Z minus Z2 upon C2. This is the Cartesian equation of lines in terms of direction ratios. Now you will see, now the angle between two lines in terms of direction ratios, what we can write? Angle between two lines in terms of direction ratios. What we can write? That is cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 whole upon root over A1 square plus B1 square plus C1 square into root over A2 square plus B2 square plus C2 square. Now this is the angle between two lines in terms of direction ratios. Now this topic is totally completed. Now I will come to the next question. Now see, condition for or condition of perpendicularity of lines. Condition of perpendicularity of two lines. So for the formula, cos theta is equal to B1 dot B2 whole upon mod of B1 mod of B2 when theta is equal to 90. In case this formula will be this formula, we can write B1 dot B2 vector is equal to 0. Now this is the condition. And for the formula, cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. When theta is equal to 90, this implies L1 L2 M1 M2 and M1 N2 is 0. So L1 L2 plus M1 M2 plus N1 N2 result will give 0. This is the second condition for two lines in three-dimensional space, that is perpendicular. And third is for the formula cos theta is equal to a1 dot a2 plus b1 dot b2 plus c1 dot c2 whole upon under root a1 square plus b1 square plus c1 square into under root a2 square plus b2 square plus c2 square. Now, in case when theta is equal to 0, you will get the formula a1 vector a2 vector a1 dot a2 plus b1 dot b2 plus c1 dot c2 is equal to 0. This is the condition. See, this is the condition for two lines are mutually perpendicular. See, now I will come to the next condition. Condition for two lines are, or condition of parallelism. Now see, condition of parallelism. Parallelism of two lines. See, now see, condition of parallelism of two lines. It means when two lines are parallel in case theta is equal to 0, when theta is equal to 0 and theta is equal to 0. Suppose these two vectors are parallel. In case, what is the condition? Suppose b1 b2 vector are parallel. Now in case we can say b1 is equal to lambda times b2 vector. So what will be the condition? Condition will be b1 b2 vectors are parallel. So what we can say? We can write L1 upon L2 is equal to M1 upon M2 is equal to N1 upon N2. This is the condition for two lines are parallel. In case their direction cosines, ratio of their direction cosines will be equal. Now for this formula, A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. This is the formula. Now see, so and in case in case of parallel, theta will be equal to 0 degree. So b1 dot b2 vector is equal to, you will get b1 dot b2 result, you will get mod of b1 into mod of b2. So in case theta is equal to 0, you can get the result. Now see, and vector b1 and vector b2 are parallel, means vector b1 is equal to lambda times vector b2, lambda times vector b2. See, now this topic is totally completed. Now see, if anyone doubts, can clear it. Now the angle between two lines in vector form, Cartesian form, and direction cosines, this is complete.